Hi there, everybody. I hope that you're having a wonderful day so far. Today we are discussing atomic symbols and different ways of noting or notations for different chemical atoms and elements. All right, so in section 4.3, one of the first terms that is defined is the atomic number. The atomic number is equal to the number of protons in an atom. The atomic number is incredibly important because it's unique for every element. That means that no two elements can have the same atomic number. It's like the DNA or fingerprints of an element. If you know that an element has an atomic number of 7, you can go to the periodic table and look for the element that has a 7 at the top of its box, and that would be for nitrogen. Down here I have a sample box on the periodic table for carbon. Carbon right here has an atomic number of 6. So that means that all atoms of carbon have 6 protons in them. Mass number is the next thing that is defined in your textbook. And mass number is the number of protons plus the number of neutrons. So this is not always unique. The mass number is pretty closely related to the number that's found at the bottom of most boxes on the periodic table, but you'll notice that these have a decimal with them, and you can't really have partial protons or neutrons. So we're going to discuss that tomorrow, but that is actually the average atomic mass. And you guys know that averages generally don't work out to be whole numbers, which is why there's a decimal there. And we're going to discuss that in more details tomorrow. So what my main point with drawing this sample box right here was that you will find the element symbol in the center of the box. Remember, if it's a 1-letter symbol, it has to be a capital letter. If it's a 2-letter symbol, it's a capital and a lowercase. You will generally find the atomic number at the top of the box. Sometimes it's in the center, sometimes it's to the top right, and then the average atomic mass is at the bottom of the periodic table. So our next question is, how can you calculate the number of neutrons in an atom, since it's not always a set value for each element? I like to use the acronym MAN, M-A-N. And what MAN stands for is if you take the mass number, subtract the atomic number, that will tell you the number of neutrons in your atom. You get to do a little math. All right, which leads us straight into our next term of isotopes. Isotopes, the prefix iso means similar, like an isosceles triangle has equal sides. Iso means similar atoms. So these are atoms of the same element with different masses. How can that happen? How can you have the same element with different masses? Well, if it's going to be the same element, it has to have the same number of protons, but it can have a different mass value because the numbers of neutrons change. Ions is the next concept that is discussed in this section. You guys should be familiar a little bit with ions because you have a list of 36 common ions that you're supposed to be memorizing. Ions occur when the number of protons do not equal the number of electrons, so there's an overall charge. I think that you guys understand that protons have a charge of +1, electrons have a charge of -1, so the protons and the electrons tend to balance each other out. In a neutral atom, you would have the same number of protons and electrons, so there would be no overall charge. But in ions, you do have a charge. So let's go down here to our sample problems. I have the chloride ion, first of all. Chloride is Cl with a -1 charge. In order to find the number of protons in chloride, I have to go to my periodic table and find the box for chlorine. When I find that box for chlorine, I look at the top and I realize that chlorine has an atomic number of 17. This cannot change. If it's going to be chlorine, it has to have 17 protons. We discussed that that's the atomic number and that's the unique number for that element. However, we can definitely say that there are not not 17 electrons necessarily, because there's an overall charge of -1. All right, since it's negative, that means that we have more electrons, which are negative, than we do protons. And since it's -1, that must mean that we have 18 electrons. We have one more electron than we do protons. So there's a -1 balance. Next, we have the sodium ion. The sodium ion is Na+1. We must look up Na on the periodic table to find its atomic number. When we do, we find that there are 11 protons in sodium. This time, since we have a positive charge, that means we have more protons than we do electrons. And since it's +1, there's a difference of 1, so there's 10 electrons. The takeaway here is that you can never adjust the number of protons, because if you adjust the number of protons, you change the element. Then you adjust your electrons accordingly to give you the proper charge. Some of you might have noticed that you basically take the number of protons and do the opposite of what the charge is. Like if I knew there were 17 protons and I had a -1 charge, I'm actually going to add 1 electron to tell me that there's 18 electrons. Over here, I started with 11 protons. Since there's a +1 charge, I take 11 minus 1, do the opposite, and that gives me 10 electrons. All right. Other ways of noting and specifying exactly what atom you're working with. Hyphen notation is a commonly used variation of note-taking. So in a hyphen notation, you will give the chemical's name with a hyphen, which is just a dash, to the mass number. All right, so our example here is carbon-14. That means that 14 is our mass number. All right, so on a quiz or a test, I could tell you, you're working with carbon-14. How many protons, neutrons, and electrons do you have? In order to determine how many protons we have to look up carbon on the periodic table. I had given you that box right here. The atomic number for carbon is 6. So that means there's 6 protons. Because there's no charge indicated, it doesn't say carbon ion, I can assume that there's also 6 electrons. That way it balances out. Now for neutrons, how do I figure that out? I commonly will see students say, oh, that's gotta be 14 because it's got a dash 14. That is completely wrong, all right? Because the mass number, remember, is equal to protons plus neutrons. So we have to go back to our little helpful hint here of mass number minus atomic number will tell us our number of neutrons. So if we have a mass number of 14 and we have an atomic number of 6 because there are 6 protons, that tells me that I actually have 8 neutrons in this particular isotope, and those are the correct answers. Sometimes, though, hyphen notation can be difficult when you're trying to note ions because it's difficult to include that charge. So we will use what is called a complete chemical symbol. Sometimes that's called a nuclear symbol or a nuclide symbol. So an example of one of those is this right here. It looks a little scary, but it's actually not that bad. All right, so let's break this thing apart. This number up here in the top right corner is always the charge, if there is one. If there's nothing written there, you assume it's a neutral atom. This number in the bottom left is your atomic number. Again, that tells you how many protons you have. And then in the top left, that indicates the mass number. And of course, then the letters tell you the symbol for the element that you're working with. So if I gave you a complete chemical symbol like this, it would be fair game for me to ask you these things. How many protons, neutrons, and electrons are there? All right, protons is equal to the atomic number. So in this case, our atomic number is 78 down here. If you weren't sure, you could also look up PT on the periodic table and find its atomic number. To find neutrons, we have to take the mass number, which in this case is 195, minus the atomic number, which is 78, and there is absolutely no shame in using your calculator if you need to. I have that this is going to give me 117 neutrons. Now for electrons, we know we've got 78 protons and there's an overall charge of +2. So that means that there are 2 more protons than there are electrons in this element. So there must be 76 electrons. The last thing is the chemical name. PT was on your original list of 40 elements that you should know, and it is platinum. I reminded students today in class that chemistry is not a class where you can just not learn something early on and then expect it to never show up again. This is a course that builds upon itself. So in the beginning, I gave you a list of 40 elements that I wanted you to become familiar with. You were supposed to memorize their symbols and their names. If you did that, this chapter is going to be much more manageable for you. If you don't know, for example, that tungsten is W on the periodic table, it's going to take you a little bit longer to find it. So if you didn't study those 40 common elements very well, I would go back and work on that some more because you're going to need to know that. Other elements not on the 40 common elements would not be fair game for me to ask you their name for. For example, PO is polonium. That is not on your list. So on a quiz or a test, I wouldn't be able to ask you what element has the symbol PO and expect your name to be for you to provide the name for me. However, if I gave you the symbol PO, I could ask you how many protons are in polonium because you should be able to look that up on the periodic table. I hope that these notes help you. Make sure that you complete the 3-3 practice problems assignment that was posted to Google Classroom.